Welcome to The Explainer. Today, we are diving deep into the philosophy of clean code, drawing on some fantastic insights from Mariano Anaya's book, Clean Code in Python. So let's kick things off with a question that seems almost too simple, but it's actually incredibly profound. Why do we even write code in the first place?
The first thing that probably pops into your head is, well, we're telling a machine what to do, right? We're the puppet masters, giving commands, making the computer perform tasks.
But, and this is the twist that changes literally everything, Mariano Anaya argues that's only half the story. In fact, it's the less important half. The real, primary reason we write code is to communicate our ideas clearly to other people. Let that sink in for a second. So if we really embrace this idea that code is fundamentally for humans, it completely flips the script on what we consider good code. Suddenly, it's not about being the most clever person in the room. It's about being the clearest communicator. I mean, just think about your own experience. How much of your day is spent just trying to understand existing code before you can even add a new feature or fix a bug? A lot, right? The cost of unclear code is massive, measured in time, frustration, and, yep, a lot of bugs. Okay, so if we're going to treat code as a language for humans, then just like any other language, it needs a clear and consistent grammar. It needs a set of rules that everyone on the team can agree on and follow. This chess study is just the perfect analogy. See, the grandmasters weren't just memorizing where every single piece was. No way. They were recognizing larger patterns, chunks of information. When our code is consistent, it creates those exact same kinds of patterns. An experienced developer can glance at it and instantly get the lay of the land. But when it's a mess, everybody becomes a novice, forced to decode it one painful symbol at a time. And you can see the difference right here. I mean, look at this. The code on the left feels like a tangled mess of wires. You have no idea where to even start. But the code on the right, it's clean, it's organized, it's like a blueprint. You can immediately see the structure. And this idea goes way beyond just, making things look pretty. It's about speaking the language fluently. In Python, we call it being Pythonic. It's the difference between using a clunky, old-school for loop versus a sleek list comprehension. It shows your native speaker, and it makes your communication way more effective. All right, so we've got our grammar, we've got a consistent style. That's the foundation. Now, let's talk about the story itself. Because truly great code doesn't just follow the rules, it tells a clear and compelling narrative. And the first rule of any good story? Don't be repetitive. It's exactly the same in code. We have a name for it. DRY, or don't repeat yourself. Every time you copy and paste a block of code, you're setting a trap for your future self. Because when that logic needs to change, you have to remember to change it in every single place. It's a recipe for disaster. So what do you do instead? You take that repeated logic, you pull it out, and you give it a clear, descriptive name by putting it in its own function. This is an absolute game changer. It separates the what from the how. Now, the rest of your code doesn't care how the score is calculated, it just knows what that function does. And this leads us to another core idea from storytelling. Every character should have one clear purpose. In code, this is the single responsibility principle. A function that does 3 different things is a badly written character. It's confusing. Good code is made of small, focused pieces that each do one thing and do it really, really well. So, we've looked at the words and sentences, the individual characters and paragraphs. Now let's zoom all the way out and see how this applies to the entire novel, the architecture of our system. This is such a great way to visualize it. You start with the words and sentences, your individual lines of code. You build those into paragraphs and chapters, which are your functions and packages. And all of that comes together to create this whole universe, your system architecture. And just like a good sci-fi universe, it needs to be logical and easy to navigate. Think about it this way. A good architecture should scream the system's purpose at you. When you look at the top-level folders, it should be obvious that you're looking at, say, an e-commerce platform. The fact that it uses a specific database or web framework, that should be a minor implementation detail, not the main plot. Okay, so we've been talking a lot of philosophy here, but let's get down to brass tacks. In the real world, why should you and your team actually invest all this time and effort? What's the bottom line? The payoff is frankly huge. We're not talking about small improvements. We're talking about new developers getting up to speed in days instead of weeks. We're talking about fewer bugs, more resilient software,
And honestly, happier and more effective developers who aren't constantly fighting the code. It's about building systems that can actually grow and adapt instead of collapsing under their own complexity.
Now, I have to add one really crucial point. These are principles. They're a compass to guide you. They are not rigid, unbreakable laws that you must follow dogmatically. Context is everything, and sometimes the pragmatic choice is the right one.
And there's no better way to say it than this classic line from the Zen of Python. Practicality beats purity. The end goal here is always effective communication and a system that works, not some abstract, perfect ideal. So I'll leave you with this final thought. The next time you sit down to write some code, just ask yourself this one question. Are you writing a monologue for the machine, or are you starting a dialogue with your team? The answer to that question will make all the difference.